I hope quick reaction about the impact on parallel programming and high performance stuff, which my take in dealing with those folks, I'm sort of one of them only occasionally, is that they don't want to change how they program, and if they would just program a little differently, they could actually win big. And I personally own the land speed record on some parallel benchmarks in Java, and some folks at IBM have had some experience on, there's nice designs that work really well on high performance applications in Java. The folks at Los Alamos, they won't touch them. So this is a culture and style and paradigm issue as much as a technical issue.
Yeah, that's interesting. Actually, my experience is that they will go to extreme lengths in changing their
so long as they can
programming
do it in
paradigm.
Fortran.
Yeah. That's not fair. I think there's been wide adoption of C++. There's all sorts of things. But I think certainly with Java, there's been, I think you're correct, a cultural problem. There's a historical problem where, and I don't mean to single out Java. I think a lot of virtual environments have the same blind spot, but there's just been no attention paid to the community. And so they look at it and they say, you guys don't care about us, we're not even going to try.
I think there's a credibility issue here for the community. As you know, people in the programming languages research community had this whole high performance Fortran effort, which had inflated expectations and did not deliver at all. So I think we have some groundwork to do as well to establish our credibility. So since I want to follow up on your comment about, virtual environments are hard to debug and get people's feedback on that, because it seems to me there are two sides to the coin. And one side you have this intervening layer that can obfuscate the runtime behavior. On the other hand, you can use this intervening layer for instrumentation and diagnosis. So there's a project at IBM called LeakBot that is very effective at detecting memory leaks because it's able to use the virtual machine layer. One could imagine other kinds of serviceability like checkpointing, portable checkpointing, migration, things get easier. So one of the things I'd be interested in here, getting people's gut reactions is if you had the choice between a monolithic, statically compiled environment on one fixed machine or this intervening virtual environment where you could put instrumentation, which is really a better environment for manageability and serviceability? It seems, what are your thoughts?
Yeah, I agree, and that's what I tried to say. I think there are two sides to the coin. I think the current situation is not good, because while the potential exists for great tools, they're not there, by and large. And so we have the problem and not the solution. We have extremely complex debugging problems, and you have to kind of feel around when you debug these issues. Of course, I agree with you. There's potential for all kinds of interesting tools, but that lies in the future.
I think we have to tease apart two things, which I think you were to some extent confusing. There's the issue of building stuff on a virtual machine environment, and there's also the issue of building stuff in a, for lack of a better term, modern way. So there are lots of, it's possible to have a non-virtual machine language which still does garbage collection. It still has layers upon layers upon layers of software and middleware and all that stuff. And I think a lot of what your comments are about bloat really relate to the layers upon layers. It's not just the final layer, which is virtualization. I think that that's a small part of the problem, if it's part of the problem at all. I think it's the confusion in the higher stuff, where people don't know what, people are invoking some library function, they have no clue what it does. That's causing the problem. It's not the virtualization. And I think that's responsible for your comments about bloat, difficulty with debugging, etc.
Right. No, that's a fair comment. Yeah. I think the bloat is much more to do with the frameworks that we've built up on top of these. Although building the frameworks has been made a lot easier.
But I think that's because of the facilities of the language, not because of the virtualization. Virtualization makes it possible to build large levels of libraries, because you don't have to worry about who's responsible for bringing both. It allows more componentization.
Actually, I think I disagree with it to some extent. I mean, part of the problem with the layer upon layer of bloat is, to some extent, with the virtual machines, because at least from my perspective, which comes really from the bottom up, a lot of the layers that are built on top of the virtual machine are there to provide semantics that the virtual machine doesn't provide. Basically, you've got an even more restricted environment in many ways with the VM than you would even on the hardware. So you end up with the first couple of layers of software providing facilities that probably ought to be provided by the VM itself. And then
Can you give an example?
Well, I'm thinking of things. Actually, I'm not sure I can give an example that will be meaningful to most of the room because I don't do Java. But things, I mean, things. Some of the more complex flow control things, closures, and pretty soon coroutines and continuations are just, no big deal. They're in there. At one point, I took a look at what would be necessary to implement continuations in the JVM, or on a language running on the JVM, and basically what you would need to do is treat the JVM as a hardware CPU that doesn't do continuations and completely re-implement, all of the flow control mechanisms. And I look at looking at things like that, where you get a very small, restricted set of semantics at the lowest level, and you find that once you start doing application programming or library programming, those semantics are inadequate, and you have to build on top of them higher level, more complex things. You start getting libraries that do all sorts of stuff, and libraries built on top of libraries, when maybe the more appropriate thing to do is push that down a level and give yourself a richer base environment and not have to keep building all these libraries on top of each other.
I'm not convinced that that's because you're trying to implement a different paradigm than the JVM is attempting to do.
It's distinctly possible. And it might be just that a lot of these libraries are written by people that ought not write libraries, but...
I think, but the bottom line is, real software is big, and therefore it has to be made modular, and layers is a way of making things modular, and if we can't deal with layers, then we have a problem. Whether, layers should be the solution to one particular problem or not, is different from the problem of you really have to be able to deal with layers.
Yeah, that's true. You probably want to deal with them in a fairly dynamic way, though, right? And I think that, some of the problems is just the static import of big wads of code that you actually might potentially use at some point in your future.
How we deal with them.
Yeah, indeed.
But the fact that we must deal with them rather than saying, oh, the problem is layers, so let's avoid layers. I think we have to deal with layers.
Do you think your comment of bloat is basically due to the fact that the design of Java, we grab large amounts of memory, and in older systems, malloc and free, we were working within a much smaller working set, so we add all these layers of things. They're all allocating memory. We get to the maximum working size, and then GC starts working, coalesces it, but the memory is still in use, and we're still, moving things around, and so our working set size is so large, we're just using too much resources on the system, and so the system feels a lot slower than a traditional old static compiled system that managed its working set size within the application. Yeah, you have memory leaks and you have all the older problems that you don't have today in modern systems, but it may be the perception of bloat rather than reality.
Wait, didn't you guys design Java for small devices?
Yeah, we did.
Yeah, I think, well, that may be.
But we don't have J2EE and applications and enterprise Java beans and...
Yeah, I think that may be one aspect of it, but of course that's very much predicated on the effectiveness of the garbage collector, I think, and the way that you tune it.
I've never seen a garbage collector that actually shrinks the working set size after it got big.
Researchers in garbage collector programming languages 10 years ago noticed that it's not sufficient to have garbage collection. You also have to not hang on to all those pointers.
Right.
And they developed very effective profiling tools to figure out whether you're hanging on to all those pointers. I'm not sure whether these are really migrated out to the development community for Java or not.
They don't work as well as you think they do in modern systems. Middleware makes it more obscure when you're not making
Yeah, it's probably because those libraries that you have to import, all those layers are hanging on to those pointers.
Yeah,
all sorts of
it's
stuff.
library design.
Yeah.
One more question,
So it's fine, mostly to answer it. So I think everyone believes in layers, and yet no one knows where to draw the lines these days, which is the subtitle of my talk, so I guess I'll continue that tomorrow.
Okay, thanks very much. Let's start the break so we have a bit of time, and we're reconvening at 10.
10 o'clock, so we've got a 7 minutes break.
Okay.
And we're going to start on time.